Good afternoon, everyone. This is Hongda Chen, the National Program Leader for Bioprocess Engineering and the Nanotechnology Division of Food Safety, Institute of Food Safety and Nutrition. I would like to take this opportunity to share my experience and observation as a NIFA representative in the National Nanotechnology Initiative. Hopefully, that I'll present some insights that match or complement to some greater points made by Jim and Steve in their respective talks. National Nanotechnology Initiative is one of the longest standing federal R&D initiative launching on January 21st, 2000 by President Clinton. In his science speech made at Caltech in that event, he articulated tremendous potential that the nanoscale science and the nanotechnology can bring about to improve national economy, strengthen national security, and improving quality of life of the citizens. He also articulated the challenges and hurdles along the way to bring the cutting-edge benchtop discovery to the technology that benefit society, hence the need of a major federal R&D initiative. Since the launching of the NNI, it has enjoyed the bipartisan support throughout all these years. Every year, in the White House memo to the Department Agency on the scientific R&D priorities, nanotechnology has always been on it. This is an example of President Bush in 2003 signed the 21st Century Nanotechnology R&D Act into the law. This is the leadership structure of the NNI. It started from the Executive Office of President through the Office of Science and Technology Policy, OSTP, and in the Office of Management and in the Budget, OMB, through the Cabinet Leadership at the National Science and Technology Council, NSTC, then it come down to the actual working body subcommittee on the nanoscale science, engineering, and technology, also called the NSET. This is a place the scientific program leaders from all of the federal agencies who participated at NI get together and then discuss all related issues and then chart the course moving forward. National Nanotechnology Coordination Office, NNCO, serves as a secretarial office for the NNI. And the National Nanotechnology Advisory Panel provide advices to the NNI, and this task has been delegated to Presidential Councils of Advisors on Science and Technology, or PCAST. The NNI performance subject to the periodical review by National Academies for Science and Technology. National academies conduct the evaluation of the NNI periodically every 3 to 5 years. The picture shown here is the most recent report prepared by the National Academies. And the program directors from participating agencies have been asked to appear in front of this review panel and then give their report of agencies of participation, contribution, challenges they faced in this cross-agency community and activity. And the program directors are responsible to answer all the questions raised by the panel in the preparation of such a report. And then the report also make a recommendation to the government as the strategic direction, implementation plan, and the various different challenge issues that they see in their advices. National Nanotechnology Initiative by law is required to frequently update and their strategic plan. The picture shown here is the most recent iteration released in October 2001. Over the course of more than 20 years, there are 6 or 7 strategic plans being released. And the opportunity to serve as the co-chair of one of those iterations, I witnessed firsthand interagency collaboration to get multiple mission-oriented challenges under this one single coherent strategic plan. It's such a great learning experience working with all the leaders in these across federal science and technology agencies. The National Nanotechnology Initiative has witnessed a healthy growth over the time. It's a science and technology impact penetrate through all the mission areas within the federal family. From its get-go, only 6 federal agencies involved in the NNI. And then over the course of the last 2 decades, now it has grown to more than 33 entities in this family. USD and NIFA joined the NNI in 2001 as one of the earlier agencies in this NNI family. Several years after that, Forest Service joined the NNI. And then a few more years later, the ARS joined this family. And collective vision of the NNI is a future in which the ability to understand and control matter at a nanometer scale leads to the ongoing revolution in technology and the industry that benefit society. And for those of you who are familiar with the NIFA's current mission statement, and then this is and to very much resonate with what we have in the agency. There are numerous benefits through such multi-agency collaborations. And first, the emerging science, out of this family, serve as a stimulation and then the inspired the scientists in the different mission areas to look at the new ways to tackle the challenges they are facing. And secondly, the collective investment in the infrastructure, R&D infrastructure, the advanced instrumentation, and then can serve as a leverage to accelerate the pace of research in different agencies. I have a numerous examples of all scientists take advantage of the infrastructure and advanced instrumentation to look at the nanoscale questions that they were otherwise unable to study based on the facilities and equipment available on their own campus. After 20 years of pursuit of nanotechnology, National Nanotechnology Initiative, we now can see quite clear the benefits of the NNI, and the nanotechnology now has penetrated through almost all aspects of our life and the industry. You can see them in the energy, in the transportation, in highway infrastructure, in the space exploration, in advanced computing, in medicine, as well as in the agriculture and food. The picture at the lower right corner is in a project supported by NIFA, using 2D carbonaceous nanomaterial called graphene, and ink printed on the leaf and serve as a sensor platform to constantly monitoring the crop stress faced to the environmental and the insects and the tags. So that provide a mechanism leading to the precision agriculture to precisely deploy the resources needed to ensure crop health. The accumulated advance of nanotechnology has positioned our scientific capability to rapid response to the critical national issues. And as we experienced the pandemic over the last 2 years, and we can see the nanotechnology has contributed to the materials used for the mask, different the vaccine delivery mechanism, and the advanced rapid sensor for detect the SARS virus. The picture on the upper left corner is the first individual receive mRNA-based vaccine. This picture was taken at December 14th, 2000. And then this is less than a year from the identified genome sequence of a SARS-CoV virus. And then think about the time that from a genome sequence to develop an effective vaccine delivery mechanism. In this case is a lipid nanoparticles. And then going through the rigorous regulatory review to ensure the safety before the public release. This whole thing only take less than a year, and this is very rapid at the pace of development. And so if you and I receive the COVID vaccine, and we are the beneficiary of the NIFA. And as indicated earlier, the NIFA has received bipartisan support over the last 20 years. This trend of a budget increase over the last 20 years from the $5 million, about $5 million from get-go to now about $2 billion annual budget, and is a strong indication of a bipartisan support. The nanotechnology R&D here at the NIFA was support benefited from the NIA, the federal agencies. And this is our first strategic planning workshop conducted in November 2002. 9 federal agencies, those are the agencies that participated in the NIA at the time, all come to this workshop, share their strategic consideration, their approaches to launching the major efforts in the advanced nanoscience to address the mission-critical issues that serve as inspiration and ideas for our scientists and the workshop participants to chart our course and suggest the direction. The workshop report was adopted by the agency, and we launched our own programs to advance nanotechnology for agricultural food shortly after that workshop. Over the course of the last 20 years, we have supported various different the nanotechnology projects across the entire field of agriculture and food. And we can see more than 1,000 projects today in our database. And the trend of a budget increase at the NIFA, as reported by our budget office, mirrored the growth trend of the NNI. By the way, this the budget data is based on a thorough analysis of cross-cutting data. Some of you may be familiar with the cross-cutting exercises for the nanotechnology. It's called the T80. And the data, and after the analysis reported by our budget office to OMB cross-cutting data call, and then reflect in the NII supplements to the president's annual budget, as depicted on the picture on the left-hand side. This report, this supplements, the annual supplements, not only timely depict the program, the agency's the nanotechnology program position, program offering in their plan, but also highlight the impact and achievements fulfilled by all these agencies. And in this particular report, in addition to the sensor that I mentioned about, another example was reported here. This is a project conducted by Jason White at the Connecticut Agricultural Experimental Station. And he studied using copper nanoparticles to fight the fungal infections in eggplant. And with less than $50 of a nano formulation of a copper spread out per acre, he can reap more than $20,000 return from the increased productivity of the eggplant. Such a great return on investment, showing the greater promise of the nanotechnology. We can also see the nanotechnology for agriculture and food system research examples in the other the budget supplements of the NNI. The rapid advance of nanotechnology for agriculture and food system and its significance has been recognized by Gordon Research Conference, a prestigious cutting-edge science conference mechanism. And we've been given a permanent spot to host a biannual conference which draw the scientists across country as well as internationally to this event. Scientists present their cutting-edge ideas through the unpublished the work, and really stimulating the idea and then inspire the science to think about the new directions they may pursue in this area. This conference also drew the attention of other federal agencies. For instance, EPA and FDA and the NNCO are regular attendees of this conference. The NNI also provided a platform on multiple interagency collaborations on a focused science area. One of the mechanisms is called the Nanotechnology Signature Initiative. This is an example of one of the NSI in the nanosensor area. The NIFA and has an opportunity to participate in the interagency collaborations throughout the various different workshops and studies to identify common challenges to bring the cutting-edge discovery in the sensing mechanisms and then to the commercial implementation in the development sensor technology to impact various different needed areas, the applications of the sensors. And this platform also provides opportunities to highlight the research that is supported by NIFA, as shown through this webinar that the broadcast nationwide. The NI also is positioned, well positioned to address emerging issues, to look at the nanoscience angle to address this issue. This is an example to look at the emerging issues of nanoplastic and microplastic, its impact to the environmental and then to the ecosystem, as well as a potential threat to the food safety. Anyone is interested to join this newly formed the interagency working group, please let me know. We also have a shining example of our colleagues who participate in some of these NSI. Dr. Jim Dabrowski has handsomely represented NIFA in this NSI on water nanotechnology interagency with group and make a significant contribution to this group. The responsible development of a nanotechnology to ensure safe, to ensure the environmental health implications being maintained at the minimum for the engineered nanomaterials. So this is one of the major pillars at the NNI. And the various different the strategy and the research gap is being identified through the interagency working group called the Nanotechnology Environmental Health Implication, or NIFA, to be short. And the NIFA has been working with other agencies, working with this group, particularly in the concern about the safety, safer deployment of technology for agriculture production, as well as to the food safety. The regulatory science agency involved all the other science agencies like NIFA in their guidelines development. And also through this collaboration, we understand some critical challenges in the science and then the gaps in the science and technology development to ensure the regulatory approval of the regulation. And this is to serve as an input for our consideration of developing adequate and RFA and then calling the research. And we have numerous examples to back it up. So with that, and then I will share the following thought to conclude this presentation. First, participate in the interagency collaboration on the scientific and technology initiative like the NSI. This is a great opportunity to represent the NIFA policy, philosophy, and then the perspective to our partner, federal agency stakeholders, and then the broader the public. We can take this opportunity to inform all our partners about what NIFA is about, our significant efforts and then the contribution to address critical societal challenges throughout our science program. In this interagency platforms, there are ample opportunities for us to participate and make a significant contribution through the various different subcommittee and the working groups in the project. And along the way, there are many leadership opportunities in doing so. As I mentioned, the example of the NI strategic plan, we can take this opportunity to practice our leadership skills and then to learn from working with broader interests represented by all these science agencies in this community. And working with other federal agencies, science and technology, and regulatory agencies, we can effectively bridge our agriculture science community with the other scientific community to foster opportunity for mutual inspiration, for the collaborations, as well as leverage with the resources and the talents that are supported by the other agencies. And then finally, this is a great conduit, and then to bridge the science policy leaders in the other agency with our agency leadership, as well as introduce the great collaborative opportunities with all the talents reflected by our NPL community. So with that, I conclude my presentation, and thank you very much for your attention. I welcome your comments and questions with regard to this presentation through the email and phone calls. Thank you. Bye-bye.